Hello, in this short video I want to show you how easy it can be to create an IoT application based on industrial proven hardware and software by Beckhoff and the ThinkSpeak IoT platform provided by MathWorks. As shown in this overview, MQTT and HTTP can be used to interface with ThinkSpeak. In the following, we will focus on MQTT, however, HTTP can also be used. Let's have a closer look on our IoT scenario. We have a Beckhoff embedded controller, and attached we have two types of terminals. One terminal is to interface with a load cell, so the terminal realizes a full bridge, and we have a vibration sensor connected to the other terminal to realize an IP interface. The load cell is of course for waiting applications, and the vibration sensor is for observation of disturbing vibrations on the system. We will use the TwinCAT PLC to scale the incoming data stream from the terminals. We will then use the TwinCAT 3 condition monitoring library to reduce the information content before we finally send the information via MQTT to ThinkSpeak using the TwinCAT 3 IoT communication library. So let's get started in TwinCAT. The TwinCAT engineering environment is already connected to our before mentioned embedded controller. Under devices, we can see the EtherCAT master and all attached EtherCAT terminals. The EL3502 is our full bridge terminal, and the ELM3602 is our IP interface terminal. We can see that the process data is already connected to some variables. We can go to link variable and from here to the definition in the PLC. Here we can see we have our oversampling arrays defined in the PLC, and we can see as a first action that we rescale all incoming data by using the sensor information and also the settings, for example, the measurement range of our terminals. In the end, we have a load signal in grams and vibration signals in meter per square seconds. The load signal is sampled with 10 kHz and the vibration signal with 50 kHz. The PLC itself runs in 1 millisecond and will reach the sample rate by using oversamples, which is why we have arrays defined for the incoming data stream. So every 1 millisecond we can get 10 samples from the load signal and 50 samples from the vibration sensor. Let's first have a look on the system behavior by investigating those signals in the TwinCAT scope. In the TwinCAT scope, we can observe the load signal in green and the vibration signal in blue. If we put some weight on the load cell, we measure around about 150 grams. Now let's induce some disturbance on the system. Therefore, I will use a fan that causes vibration. Let's put it on, and we can now see that both the load cell and the vibration sensor detects the disturbance. Let us now investigate the vibration signal a bit more in depth. For this, I prepared a small TwinCAT analytics project with only one single algorithm inside, which calculates the magnitude spectrum of our vibration signal. You can see here is the vibration signal as input, and we can see the parameterization of the Fourier transform. If we run the project, we can already inspect in the reference scope that we clearly have a base frequency at approximately 35 Hz, and we can see the first and second harmonic of the system. Now we increase the strength of the disturbance, and we can see the harmonics increase. Let us use this information to reduce the information content of the vibration signal. We therefore use the multiband RMS function block from our condition monitoring library. The function block calculates the FFT of a signal based on a defined time window and integrates the spectral power density of user-defined spectral bands. In this case, we define the spectral band around the pre-mentioned base frequency, first and second harmonic. Hence, we reduce the information content from a 50 Hz signal to 3 values every 2 seconds. Let's now publish this data to ThingSpeak. For this, I've created an FB ThingSpeak instance of FB underlying ThingSpeak, which is user-defined here. Here I've declared an instance of FB IoT MQTT client, which is defined in the TC3 IoT base library. This is basically the core of the complete source code. We can see that we, in the first cycle, need to parameterize the MQTT client. First, we set the host name, which is mqtt3.thingspeak.com. And then we need to define the host port, which is port 8883, which is the encrypted port. We use the TLS version 1.2. And we need to provide the ThingSpeak certificate that I previously already downloaded from the ThingSpeak webpage. Then we need to set some account settings. And for this, I will change to the ThingSpeak webpage. Here under devices, you can configure MQTT devices. I already have one, so I click edit and I provided a name. I have here my MQTT credentials that I need to insert in my PLC. I have a client ID, username and password, and I have authorized channels connected to this MQTT device. And we'll see that those channels are also configured in the PLC if we investigate the publish and subscribe topics. Here we see the account settings one more time. So client ID, username, password. And here we see that we connect a message queue to the MQTT client for receiving messages. Here we connect the client to ThingSpeak. And here we already see the message queue. So in this as payload receive variable, we will get the payloads that we get from ThingSpeak. Once we are connected, we can set the subscription under a certain topic. So here we have the channel number, and we subscribed on channel 4 in this case. In the following, we will publish every 2 seconds. First of all, we get a timestamp from our system, and then we build the payload string, which is vendor specific and defined by MathWorks in the documentation. We therefore have created a method to create the vendor specific string out of the first, second harmonic and the base frequency, and also we publish the load signal itself. Once we have our payload string ready, we just call the publish method and send over the payload. Now let's check our channel. We have here our channel visualization, and we can already see the data streaming to ThingSpeak from our PLC. So we see the base frequency, first, second harmonic, and also the load signal. If I unload my load cell, we can immediately see the change in the load signal. I can also activate the fan again, and we will see that now the values of the base frequency, first and second harmonic, already increase. I can also enlarge the vibration by running the fan in a stronger mode, and we can see base frequency, first and second harmonic, still increasing. Let's quickly switch back to TwinCAT and log into the PLC to also inspect that we receive data back from ThingSpeak. So remember, we subscribed on channel 4, which is the load signal, and here we can see something around 7 grams. And if I apply again my weight, we see it's now increasing to again 150 grams. If you want to learn more about integrating or interfacing with MathWorks products like Simulink, MATLAB or ThinkSpeak, just visit us under www.beckhoff.com/MATLAB.